Okay, so next topic that we will be going through is the evolution of microprocessor and different types of microprocessors. We will be going through that. And with respect to that, we will also say like what different types of computers are there, how they are defined based on their different generations. So like there are different mobile generations are there. Similar to that, there are different generations to the computer system that we see today, and the computers that were around 2 to 3 decades past. There are very much difference between these computers. So that difference can be correlated with the evolution of microprocessors, like how the microprocessors have evolved from a very uh, small number of bits at a time execution or to a large number of bits execution at a time. Okay, so we'll be starting with the evolution. So here basically these microprocessors are made up of basically the transistors. So these transistors are the basic building block of our electronic circuits. Either mobile phones are there, or computer systems are there, even microprocessors are there. So the transistor was invented in 1948. So before that, we were having vacuum tubes. So before these transistors, we are having vacuum tubes. So these vacuum tubes are of very large size. So to replace that, we were having the new technology that is called the transistor that was invented in 1948. So after the invention of transistor, so it was like if one transistor is fabricated, another transistor is fabricated. If we are going to have a transistor and we are going to use these transistors for a particular application, so if we consider a basic NAND gate or even NOT gate, so a basic NOT gate is made up of two different transistors. In case of NOT gate, or you can say inverter, there are two transistors are used. So you might be knowing this. So in inverter, so this is the symbol of a transistor. So this is a PMOS and this is NMOS. This is one transistor and this is another transistor. And from here we are going to give the input, and here we are going to get output. And this is the VDD and this is ground. So to implement a basic inverter, we need to have two transistors. So similarly, if we are going to implement a logic like a adder or any encoder or decoder, we need to have different type of logic gates. So these logic gates are made up of different transistors. So if we are going to use individual transistor for designing suppose adder, so for adder, for even half adder, we know for XOR gate and a AND gate is used. Okay, so this is sum and this is carry. This is A and B. So if this is a single half adder, but these gates are made up of transistors. And if these transistors are suppose individually fabricated, then you can just consider the complexity of this half adder. So inside this half adder, how many transistors are there? You can just imagine. So here, like if AND gate is there, to implement an AND gate, we need to have like around 5 or 6 transistors are required to implement an AND gate. If a NAND gate is there, we need to have 5 transistors only. Similarly, for XOR gate, we need to have larger transistors, large number of transistors. So as we are having a single transistor, we are going to implement a particular logic circuit, and these logic circuits are going to make a processor. These smaller logic circuits are going to implement the processor. So we can think in that way, like we are having the requirement of large number of transistors. Okay, but the transistors were invented in 1948. So after 10 years, there was the invention of ICs. So ICs are going to make our life much easier while fabricating a processor basically. So here, instead of one transistor, fabrication of one transistor, suppose this half adder is going to have 6 plus, suppose this one is going to have at least as 8 transistors. Okay, suppose these are going to have 15 transistors. So 15 transistors, individual transistor you need to connect, and then you will be getting the half adder. But as the IC invention takes place, what happens? So instead of going to have 15 transistor fabrication and then connecting all these together to form a half adder, a single IC chip is available, and this IC chip is available so that we will be having a simple one structure. Inside this, different transistors are embedded. Okay, and these embedded transistors are so fabricated like they are connected to each other, and they are able to give the input from the input, and we can get the output. So here it will be A, B. If it is half adder IC, so it will be A and B, and we will be getting the output. One VDD will be there, and one ground will be there. So instead of using 15 transistors and making the connections, we can have the simplified version of the same block half adder. So the IC invention has basically created very much opportunity in terms of electronic device fabrication. Okay, so basically this IC was invented in 1958, that is after around 10 years from the transistor invention. So this IC was invented by Texas Instrument. Okay, and this transistor was implemented in Bell Laboratory. Basically, this Bell Laboratory was one of the renowned laboratories that works in this field. After that, the first microprocessor was invented by the Intel. So here the full form of Intel you can consider here integrated electronics. Okay, so the in short form we know Intel. So its full form is integrated electronics. Okay, so Intel was the company that first fabricated microprocessor. So the first microprocessor was basically invented in 1971 with the name 4004. So this 4004 indicate like it is of 4-bit microprocessor. So what is the meaning of 4-bit microprocessor? Yes, anyone?
So it can take 4 inputs at a time, also 4 commands at a time.
Okay, anyone else?
It deals with 4-digit binary.
Okay. Okay, so basically, so if the size of a microprocessor is 4-bit, it means microprocessor can process 4-bit at a time. That means if any instruction is there, if microprocessor is going to operate with respect to that instruction, then it can operate only on 4 bits at a time. If suppose it is a 4-bit adder, we want to have a 4-bit adder, then it can do the operation of adding 4 bits. But suppose we need to add 8 bits. 8 bits data, like A is also 8-bit and B is also 8-bit. So this a microprocessor that is of 4-bit cannot add this 8-bit data, or if it is like configured, it can add 8-bit data, but it will be adding 4-bit at a time, then another 4-bit at a time. So if a microprocessor is of 4 bit, it can process only 4 bit data at a time. Okay. So similarly, if we are having a microprocessor that is of 8 bit, that means it can process a data that is of 8 bit at a time. So only 8 bit can be accessed, or it can operate only on 8 bit at a time. It cannot operate at 16 bit at a time, but it can add 16 bit in terms of 8 bit and 8 bit. Okay. So this is about the size of microprocessor. So sometimes you might be confused about like what this is about. So it's not like it is going to have 8 instructions at a time. It is about, it is going to add 2 data of 8 bit at a time. Okay. So then similarly for 8 bit microprocessor, the first one was 8008. So I think you might have gone with the microprocessor class, or you might be going into your coming semesters. So you will be coming out to study the 8085 and 8086. So 8085 is one of the most frequently, at that time it was most frequently used 8-bit microprocessor. So, and its structure, architecture and structure and its operations are very simpler. So that's why it is taken into a course, so that we can have a basic understanding of like how the microprocessors are there and how they basically do the operations, and how they take the input and how they give the output. Okay. And what different addressing modes are there. So here it is of 8 bit, but here you can just note it down. It is having a 16 bit address lines. So all others like microprocessors who are having like if 4 bit, if we talk about, it will be having a 4 bit or different address lines. But in case of 8 bit, 8085 is having 8 bit microprocessor. It is of 8 bit microprocessor, but it operates with address line of 16 bit. Okay. That means if a memory is there, this memory will, each slot of the memory will be storing 8 bit. Okay. But the address that is going to locate this 8 bit data will be of 16 bit. Address will be of 16 bit, and at that particular address location the data will be of 8 bit. The next one is a 16-bit microprocessor. So the basic 16-bit microprocessor is just the modification to 8085, that is 8086. So basically some shortcomings, or you can say the disadvantage of 8085 was there. So in 8085 it was like we can have only one instruction into the program counter at a time, and then only if we want to have the access of a particular instruction, suppose add instruction is there, it will be, its address will be going to program counter, and then it will be fetched, then decode, and then execute. So this is the process in case of 8085. But in case of 8086, it supports basically the pipelining. So there was a requirement like, why don't we pre-fetch some of the instructions? Suppose 1, 2, 3, 4, 5 instructions are written. So up to 6 instructions, suppose we are having 15 instructions. Okay. So in 8085, it is having the property like it can pre-fetch 6 instructions at a time, and the fetching part is different. Okay. And the execution part is different. So in this 8086, 8085, the architecture of the processor was basically such that the fetching, instruction fetching part and the execution part were in the same block in case of 8085. But in case of 8086, it is of two different blocks, or two different you can separate blocks are there. So this is called bus interface unit. This is called execution unit. Okay. So in that case, bus interface unit are able to fetch 6 instructions and store into a queue. Okay. So into a queue, it can store up to 6 instructions by fetching the instructions, and decoding and execution will be done by the execution unit. Okay. So this basically supports the pipelining, like it can fetch, pre-fetch and then execute. So fetching time, it is able to accommodate into that execution time only. And also in case of 8086, it supports multiply and divide instructions. So in case of 8085, there is only addition and subtraction related operations are there. For multiplication and division, we have to use the same addition and subtraction itself to perform the multiplication and division also. But in case of 8086, there is a specific instructions related to multiply and divide. And also here, the instruction here, data bit is 16. So 16-bit data bus is there and 20-bit address lines are there. So in case of 8085, it was 16-bit address lines were there and 8-bit data bus was there. But in case of 8086, it supports 16-bit and 16-bit data bus and 20-bit address bus. Okay. So in terms of, you can say the complexity also. So here the number of instructions, number of transistors you can consider. Here 2300 transistors were there. Now you can consider here like 29,000 transistors are there in 8086. Also you can compare the speed. Okay, so here the speed is 740 kilohertz. So speed is like, this is clock speed. So clock speed in the sense like, if the clock speed is high, or you can say the clock frequency is high, then it is going to take less time to execute a particular instruction. So it is going to take less time to execute the instructions. That's why once we go for purchasing a laptop or any even mobile phone, what we do is we think about the processor, what the processor is and what is its speed. So that is speed like the frequency, what is the processor frequency is there. So based on the frequency, we can say like this, if that particular processor is having 4.77 megahertz frequency, clock frequency, and another one is having 6 megahertz, that means 6 megahertz are able to have higher speed. Okay, so that means higher speed in the sense like it is going to have large number of instructions execution per second. Okay, so it is again a parameter is given, instructions per second. So you can just see in 8085, 8086 and 8088, it is 2.5 million instructions per second, that is the same. But in case of 80286, it is having 4 million instructions per second. Okay, so because of this is because of the variation in the clock speed basically. So another one is 32-bit microprocessors. So these are some of the 32-bit microprocessors are there. You can just see the clock speed and the complexity in terms of number of transistors it is going to use. So you might be knowing about the Pentium. So there was a time in 1993, it was the Pentium that is invented basically. So here the clock speed was 66 megahertz. Okay, and it is having like an extra memory like cache memory of 8-bit. Okay, and instruction memory of 8-bit for the data. Okay, so there was an introduction to cache memory was there in the Pentium, and finally we are having the 64-bit microprocessor. Okay, so 64-bit microprocessor comes like Intel Core 2 and Core 2 Duo are different variations of Core 2 are there, and again i3, i5 and i7. So you can just compare the speed. Okay, so the latest processors are of 64-bit only. Why not 128-bit microprocessors? There is no need of 128-bit operation because you can see here it is not given basically. So basically what happens, suppose address lines are there. So like we have seen address lines of 16-bit. So if suppose address lines are of 16-bit, so there is a range. So suppose address are from 0 to okay. So these are the address lines. Suppose 16 address lines are there. So starting with 0 up to 1111. Maximum value can be 111. So we are having so we are having suppose like it is 0 0 0 0 hexadecimal to F F F F hexadecimal number. Okay. So this is the possible range of addresses that this microprocessor can you can say access. So this is total possible is around 64 KB of data. Okay. And similarly, if we talk about the 20-bit address lines, then it can have a 1 MB data access. So as we are going to increase the address lines, okay, we can have the range like what data we can access. But in case of if we are having 128-bit of microprocessor and also 128-bit of address lines, then we will be having like very large amount of it comes around in byte of data. So actually we don't require that much of data to access at a particular time, or we don't practically deal with that much of data. So there is no need of 128-bit of microprocessor basically. Okay. So these microprocessors can be divided into different generations, we can call it. Okay. So the first generation is from 1971 to 1972. The era of first generation came, which bought microprocessors like Intel 404 and Intel 808. Means up to 4-bit and 8-bit are considered as the first generation. In the second generation, basically the enhanced version of 8-bit microprocessors basically. Okay. So in that case, we can call it like it is 8085. Okay. So basically it is 8085 enhanced version of 8-bit microprocessors, because they are having like 8-bit are there, but with 16-bit address lines. So they are a bit more you can say uh, efficient. They are in terms of like able to access large number of data, and they can accommodate different instructions to operate different functions to consider that. In the third generation, it is basically a 16-bit microprocessors are considered as the third generation microprocessors. So here we are able to handle the 16-bit data at a time. Previously we are having 8 and 4 only. In the fourth generation, that came into existence of between 1981 to 1995. Basically, here it comes with 32-bit microprocessors. So basically, in terms of like mobile phones, we see the generations one first generation, second generation, and third generation, and fourth generation. Similarly, the generation comes with like 3G, 4G, 5G, similar. Okay, so here as the advancement of the technology is going to have, we can have a better, you can say, generation. Similarly, in fourth generation, we are having 32-bit microprocessor. Similarly, in the fifth generation, we are having the 64-bit microprocessors. So based on like what number of instructions a microprocessor can handle at a time, we are dividing basically the different generations of the microprocessors. In terms of types of microprocessors, we can just go through it like here. Complex instruction set microprocessor. So CISC processors basically we call it. Okay. So complex instructions microprocessor or complex instruction set computer, we can call it like. So here the processors are designed to minimize the number of instructions per program and ignore the number of cycle per instruction. So it's like complex instructions set computer. So here basically we are going to minimize the number of instructions per program. So if a program is there, in that we should be minimizing the number of instructions, instead of like if the number of instructions number of cycles per second per instruction, what it is going to take, that we will be ignoring. But our main motive is basically to reduce the number of instructions per program. That means a single instructions instruction is able to accommodate more functions. So if a single instruction is able to accommodate more function, we can have the complex instruction, because the name is suggests complex instruction set microprocessor. So we are going to reduce the number of instructions per program. That can be done like a single instruction can be accommodated to have a large number of functions. It can even like add, and also it can shift. Okay, so like that, a large number of functions can be included into a single instruction. Then it will be considered as complex instruction. So then the instruction, it will always be like complex only when we are going to accommodate large number of functions into a single instruction. Okay, so here the compiler is used to translate the high level language to assembly language because the length of the code is relatively short, and an extra RAM is used to store the instructions. So basically here the compiler, what the compiler is basically, so if high level language is there and we are going to convert it into a low level language, we need a converter basically. So that converter can be a compiler. So that converter is a compiler. So high level language means a language that is understandable to humans, you can consider. A low level language is language that is machine understandable. Okay, so machine understandable in the sense like if a machine language is there, machine language like object code, if whatever the instructions we have written, it is converted to a machine understandable form, that will be in machine understandable language. So here compiler basically translates from high level to low level. Low level here is assembly language. So here in assembly language, basically assembly language we will see later into this unit only. So your assembly language is the language that is also understandable to humans, because it is going to use the mnemonics. Okay, and also, but it is considered as low level language. So low level language, because so this low level language, it will be depending on the on which it is going to operate. Okay, so basically it is OS dependent. You can call it OS dependent. So these assembly language level language and machine level language both are low level language. Okay, so these are specific to a machine on which it will be working. So it will be like on where it will be working or on which platform it will be working. It will be depending on that. So it cannot be assembly language program cannot be run on like all like Windows and iOS and Android. It's not like that. It will be like assembly language program is there, so it will be running on the machine on that platform only where it is specified to be working. It's like machine language is there. If it is converted to a machine level language, it will be only understandable to machine only. Okay, and it cannot be like it is given to this machine. Same machine language code can be given to other machine. It will be not working. Okay, so it is machine dependent. Basically, the platform dependent, you can say machine dependent or OS dependent. Okay. These processes can do tasks like downloading. Yeah, different processes have different functions. Yeah, similar functions will be the other one. There are some examples. So similarly, the next type. So this is complex instruction set microprocessor is there. Sometimes we call it like complex instruction set computer. Okay, so this is CISC. We call it CISC, CISC. And another one is reduced instruction set microprocessor, or we can call it reduced instruction set computer. So this is RISC, RISC. So CISC processor and RISC processors. We basically generally call in that. Okay. So here in reduced instruction set microprocessors. So as in the complex one, we were going to reducing the number of instructions per program. Okay, that means we are going to make the instructions complex. Okay, that's why it is complex instruction. But in case of reduced instructions, these processors are made according to function. They are designed to reduce the execution time, okay, by using the simplified instruction set. So here we were having complex instruction. Our main motive was to reduce the number of instructions that we are going to use into a program. But whatever time it is going to take, we are not controlling that, we are ignoring it. And the opposite to that is we are going to have large number of instructions, but we are controlling the execution time of that particular instruction. Okay, so these two are the different type of processes basically. So they are carry out small things in a specific command. So here the small things, it can carry out small things in a specific command. So there is different instructions defined for even the basic function also. But in case of complex one, what it will be, two functions or three functions or large number of functions will be incorporated into a single instruction. But here for smaller work also, they will be having a separate instruction. Okay. These processors complete commands at faster rate. So here, because it is having individual functionality, is having individual instructions, and as the instruction is small also, they will be taking the lesser time overall. Okay, they require only one clock cycle to implement a result at uniform execution time. So as the instruction, most of the instructions are like defined for each instruction, each operation. All the instructions have almost similar time of execution basically. Okay, there are number of registers and less number of transistors. So here large number of registers, in the sense like registers are a type of memory. Okay, so these registers we will see later into this class. So this register is like, what we do is we have studied like flip-flops. We know flip-flops. It's a memory. Yeah. So basically the flip-flop here is, it is a type of memory, a memory that will store only one bit. If one flip-flop is there, it will be storing one bit at a time. So this flip-flops are the basic fundamental unit of a memory. Okay, so you can say the smallest possible building block of a memory region. So these flip-flops are combined to make this registers. Where it is? Yeah, this registers. So each CPU, in that we have seen like the CPU is the core of the you can say heart of the computer. Okay, so here are the processor basically. So in CPU there is registers also. So in CPU we have seen ALU is there, and along with that control unit is there. Along with this there are registers. These registers are used to have temporary storage of data. Therefore temporary storage of data basically. Okay, and these registers, so one flip-flop can store one bit of data. Similarly, if microprocessor is of suppose 8-bit microprocessor is there, then it will be having registers of size 8-bit. Okay, so here the registers will be of 8-bit. These registers are called general purpose or special purpose registers. Basically these are temporary storage. These basically do the temporary storage. They are inside the CPU. Okay, so if it is of 8-bit of microprocessor, it can store 8-bit of data. That means we need to connect 8 flip-flops. So flip-flop 1, flip-flop 2, 3, 4, 5, 6, 7 and 8. So if 8 flip-flops will be connected in that way, this combined will be considered as a register. One register of 8-bit. Okay, so these are the smaller blocks are flip-flops. So register that is inside the CPU basically consists of flip-flops, and one flip-flop can store 1 bit. So if a register of 8-bit is there, that means that register is made up of 8 flip-flops. And registers are the fastest type of memory. So these registers are fastest type of memory. Say in case of all different memories, registers are considered as the fastest memory. Even if we go with the RAM, ROM, hard disk, SSD, all these are the memories, but registers will be having the fastest speed. Okay, you can just think of it and note it down. Okay. The next one is superscalar microprocessors. So these microprocessors are performed. These microprocessors can perform many tasks at a time. Superscalar, they are, you can say, application specific. You can consider. So they can be used for ALUs and multiplier array, and they have multiple operation unit and perform task by executing multiple commands. Okay, so superscalar microprocessors can have different tasks at the same time, basically used in ALU and multiplier like arrays. Okay, another one is application specific integrated circuit. So this is called ASIC. So application specific integrated circuits are basically the role of basically microcontrollers. What microcontrollers we use? So microcontroller is nothing but a computer is basically a computer is there that is going to operate a particular specific application. So ASIC applications are basically going to use the microcontrollers, or you can say a basic operation. So here these processors are application specific, like for personal digital assistance computer. They are designed accordingly to proper specification. So based on, like, if ASIC, we are going to have a ASIC design based on the application these processors are designed. Okay, they are called application specific integrated circuit ASIC processors. These DSP processors, basically digital signal processing microprocessors. So basically based on the digital signal processing, these are also this application specific processors. So DSP processors are different from the general purpose computers processors that we basically use. These are basically specified in terms of like digital to analog and analog to digital converter, because it is going to have a processing of a signal. So it needs it will basically having analog to digital converter and digital to analog converter, so that it will be able to get the input in analog form or digital form, and it will convert to another form. So we'll just overview the microprocessors. So like, what is the advantage? So basically it is high processing speed is there, compact size, easy maintenance, and can perform complex mathematical operations, and it is flexible, like it can be having so one microprocessor is there, it can be upgraded to another microprocessor with some modifications, can be improved according to requirements. Okay, based on the requirement we can have some modifications also. So we have seen the different modifications in different generations. The disadvantage of microprocessor we can have is, as it is going to have high speed and it is of compact size, so there is a problem of overheating. So overheating is one of the biggest problem in terms of computer devices basically. So because of this overheating, we face a lot of, you can say, problems, and even the cost of the laptops and like computers basically increase because of implementing new overheating avoidance technologies. Okay, so because of that, it is going to increase the computer cost also. The performance depends on the size of data. So size of data, because we have already seen, like, based on the size of microprocessors, it is going to operate on different speed and different instructions they can execute at per second basically. So the performance will be depending on the size of the data. And large board size, then microcontrollers. So microcontrollers are application specific. So in terms of like microprocessors, they are having a larger board because they are going to accommodate large functions. But in case of microcontrollers, it is going to have a specific single function, you can consider. Most microprocessors do not support floating point operations. Okay, we will see that into the second unit. Okay, so the microprocessors basically do not support direct floating point operations, so they need to have some modifications. So we will see into that the next one. So next part we will be seeing is different generation of computers. Okay, so here we already know, like a computer is an electronic device that manipulates information or data. It has the ability to store, retrieve, and process the data. Okay, so we can just see different types of or different generation of computers. So the first generation were between 1946 to 1959. So just we can have a reference. So in 1948, the first transistor was implemented. Okay, and 1958, it was the IC that was implemented. Okay, so you can just see from here. So it is the first generation of computer was designed in 1946, that is prior to transistor. So prior to transistor in the sense like it was going to use the vacuum tubes. So when it is going to use the vacuum tubes, and vacuum tubes are of very large size. So as we have seen, if we are going to implement an inverter circuit, we need to have two transistors. Similarly, if we want to generate a computer, so computer is basically here in terms of like calculator was implemented at that time. So electronic, numeric, integrated, and calculator. So ENIAC stands for. So initially it was the calculator that was implemented. So calculator is nothing but a computer that does the operations. So that was implemented with the help of vacuum tube. Okay, and that was having the size of a room basically at that time because of the vacuum tubes. Okay. So when the IC and transistors were implemented, the next generation of the computers have started basically. So there are different examples it is given. So advantage we can just see, it made use of vacuum tubes. So at that time it was like advantage to have a vacuum tube, which are the only electronic component available during those days. So at that time there were no transistors, so only vacuum tube was the electronic device to implement that type of can say calculators. These computers could calculate in millisecond. So at that time they were calculating in millisecond, but now in nanosecond even smaller time is going to take. So the disadvantage is like there were very big in size. Weight was around 30 ton. So you can just see it was a calculator of 30 ton. Okay, so that just you can see what was the case in case of first generation. So that was also for that time it was a discovery that can change the human life. So we can't compare from today's computer system, but yeah, definitely instead of nothing it is having something, but it is of very large size. Because of this vacuum tubes only it was having the size, because vacuum tubes are basically one transistor is of like a laptop size of a laptop, a single transistor was implemented. So that's why it was going to take the larger size. Also there are different disadvantages we can just see. It was like these are based on the vacuum tubes. Here it was given in terms of like disadvantage. So vacuum tubes were of very large size, and also it was very costly and inefficient and unable to like that, like our mobile phones we are able to port it from here to here, but if it is of 30 ton we can't place from one place to another, can't take from one place to another place, like they are not portable basically. In the second generation, started with 1959 to 65, the period of second generation computers started here. The second generation computers were based on transistors instead of vacuum tubes. So next generation came is like based on the transistors, because by that time the transistors were implemented. So here also, due to presence of transistors instead of vacuum tube, the size of the electronic components decreased. This is the advantage. Okay, and it is also like low cost than first generation and better speed and better portability as the size is also reduced. The next is the cooling system was required. So you can just see the cooling system. It was the one of the disadvantage at that time, like in 1959, okay, and 65. So and nowadays, as the size of transistors are very small and large number of transistors are implemented on a single chip, it is the worst in case of like electronics circuits basically. As the complexity is going to increase in terms of transistors, the cooling system they should be requiring is a better and better one. Okay, so it is always a disadvantage, because if we are not providing the better cooling system, our system is going to collapse basically. And also here a constant maintenance were required. Okay, so constant maintenance were required, only space used for specific purpose. So at that time it was only used for specific purpose. The third generation is there. So as the IC were implemented now, so in case of transistors we were using like different transistors we were using, but now we are going to use the IC. So as we are going to use the ICs, it is further going to reduce the size very much, and also here the cheaper as compared to second generation. So because a single IC, if you go per purchase, it will be of 1 to 2 rupees. Nowadays you can get like 50 pesos, you can get an IC. So that much is the cheaper is the ICs. So that's why cost of the electronic system or computers are reduced once the ICs were implemented. They were fast and reliable also, and also it is requiring less maintenance, because if you have added 10 transistors are there, you have connected with wires. Okay, so whenever a wire is loose, our functions will be different. But instead of having a wiring of 10 transistors, we have a single IC. In this single IC, all the connections are inside this IC. So it is very less maintenance is required in case of IC based circuits. Okay. This generation, big storage capacity. Generation of computer has big storage capacity. Instead of punch card, mouse and keyboards are used for inputs. Okay. So next, the disadvantage here we can say here is IC chips are difficult to maintain. Maintain in the sense like we need to put it under a certain temperature, like based on uh, based on like different inputs and outputs. We need to have different chips, and these chips, like if it is damaged, our circuit is going to fail basically. So here the IC are basically like in terms of if we compare in terms of transistors, the ICs are going to require less maintenance, but still they are requiring the maintenance, because as the ICs are having different large number of transistors are there, and it is going to perform some operation. So heating problem in case of the ICs are very high. So that's why there is, instead of cooling system, they need air conditioning is required. Okay. And also at that time, the IC designing technologies were not that good. You can say that not that was not sophisticated. But nowadays we are having very fine IC designing technologies. But nowadays at that time they were not that much efficient. So that was also the problem in case of IC based computers. The next computer came. So here in the fourth generation, here basically it is based on the microprocessors. So microprocessors we have seen were started with 1971 basically. So the first microprocessor of 4-bit were developed in 1971. So we have seen the first microprocessor. So from 1971 onwards, we have another generation of computers, because we are going to use the microprocessors. And also graphical interface were basically came, and also here logical and arithmetic functions are performed in any program. So basically here we have the ALU concept, and logical functions we can do So as the microprocessor came, further the size of computers are going to reduce further. Okay. So also in terms of like speed, the fastest in computation and size it get reduced as compared to the previous generation of computers. Okay. So its speed increased many folds, and also the area requirement is reduced. Okay. Heat generated is negligible here. So heat generated is negligible nowadays because all the components are incorporated into a microprocessor. But at that time, the microprocessors were of 4-bit and 8-bit only. Okay, so that's why less number of transistors were used, and that's why it is having less heat generation. Okay, but at that time, the fabrication again, that we were not having that much of a better quality of fabrication, so it was also the disadvantage. Okay, and here also cooling is required, means air conditioning is required. Fifth generation is like 1980 onwards. So after 1980 and onwards, we are having like the generation based on artificial intelligence. So this is like we are having artificial intelligence based competitions we were having. So basically, in case of fifth generation, we are having the devices that are going to learn from the inputs basically. Okay. So they are able to get the input from the user and their understanding. And also the in terms of fabrication, we are having the technology like ultra large scale or VLSI and ULSI technologies were introduced, and we were able to have better quality of fabrication of the devices and microprocessors and different devices. Okay, so it is more reliable and was work faster, and it is available in different size and unique features. It provides computers with more user-friendly interfaces, so and with multimedia features also. Okay, so now the disadvantage came is like here they need very low level language. So low level language in the sense like the language that is understandable to machines only. So that's why there were requirement of high level languages. Okay, and they may make the human brain dull and doomed. So basically, instead of humans performing the operations, the computers are going to perform. So they are affecting the brains of the humans. Okay, so nowadays same is going on. So this is all about different computer generation and microprocessors. So that's all from the today's class. Thank you.